All right. Hi, everybody. Day 2. How's everybody doing? We still got a few minutes before class starts. You want to say hello in the chat so I can kind of get an idea for who's here? I mean, if you don't want to say hi, that's also fine. Miriam, right on time this morning. Good to see you. Emma, figured out how to comment on the stream today. That's great. That's great. Cal, good morning. Looks like there's about 7 or 8 of us here at this point. It's not bad. Maddie, good morning. And to all of you watching the replay after class, good afternoon or good morning. All right, about another minute or so and we could get started. Thought you might want a second Dr. Wessel Couch in the stream today. Hello, James. Looks like I got some family in the stream again today. All right, well, it's great, 1 o'clock. Where are you from? If it's 1 o'clock, I don't know the time zones, but while you guys comment in the chat, we could join in on the simultaneous sip. So if you have your coffee ready, please join me. All right, and throw some sips in the chat if you joined in on that. All right, James, but you can't be flooding the chat the whole time. I have to actually teach this class here. Okay, so the plan for today and for the next the rest of the week and next week is to do chapter 5. Okay, so we'll start with 5.1 and we'll see how far we can get with that today. We're probably not going to finish 5.1, but we'll get started at least. So chapter 5 is eigenvalues and eigenvectors. Okay, and section 5.1 has the same name. Okay, so before we let's take a look at an example, and it's going to motivate us for our definition. Okay, so example, and hopefully this is a warm up. So let A equal the matrix 3, 1, minus 2, 0. U be the vector minus 1, 1. And V be the vector 2, 1. Okay, and what I want you to do is sketch U, sketch V, and then sketch A times U and A times V. So that you're going to sketch 4 vectors here. Okay, so our answer, I'm not going to write it out. Yeah, I'll give you a few minutes or about a minute to try to work this out. We will sketch these as directed line segments in the XY plane. Okay, so I'll give you about a minute. Feel free to, but if you have anything you want to say in the chat, go right ahead. Okay, so I don't know if that's enough time for you to solve it, but either way, we already know what u and v are, so we can just plot those. So u is the vector negative 1, 1. So remember that means we go negative 1 in the x direction, positive 1 in the y direction. So this is the vector u. And the vector v is 2 in the x, 1 in the y. Okay, and so we should compute what AU and AV are. So u is negative 1, 1. And so we get negative 5, negative 1, which is a vector maybe out here. And I apologize for the spacing. I'm going to do the computation here just so we have this whole board for the next example. So AV 3, 1 minus 2, 0 times the vector 2, 1, which works out to be 4, 2. Okay, so nothing really crazy there. The screen looks blurry. Is that true for everybody? Maybe try refreshing, Shutong. And it takes the vector v and it just stretches it. It doesn't rotate it at all. It's good now. Okay. I guess the best suggestion is the notes are on Canvas, so maybe follow along with the notes on Canvas as well if it gets blurry. Eigenvector of the matrix. So we'll write this down as a definition. An eigenvector of an n by n matrix A is a non-zero vector x such that ax equals lambda x for some scalar lambda. Okay, and before we get to what an eigenvalue is, what this is saying is if you take a vector x and multiply it by a, what happens is you stretch the vector. Okay, so an eigenvector is a vector that gets stretched. It doesn't get rotated at all. It just gets stretched by multiplying by a. We call lambda the eigenvalue. Okay, so we call a vector that satisfies ax equals lambda x an eigenvector. And then conversely, if there's a scalar lambda that has where this has a non-trivial solution, then lambda is an eigenvalue. Okay, so these are what we're going to be dealing with for the next few classes. We're going to come up with some techniques to find eigenvalues and eigenvectors, and then see why they're of interest. Okay, so let's take a look at an example. So we'll let A be the matrix 1, 5, 6, 2. And we'll let U be the vector 6, negative 5. And V be the vector 3, negative 2. Okay, and the question is, check to see if either U or V are eigenvectors. Okay, and so I'll give you a minute to try to work this out. If anybody wants to share an idea in the chat of how they're going to do this, and if there's any feedback about the stream quality, like if the screen is blurry, like Shutong suggested, let me know. I'm still trying to work this out. Right, so what you want to do is check if you multiply one of these vectors by our matrix A, does it stretch our vector? That's basically what it's just checking. If we multiply by A, does the vector get stretched? All right, so to solve this, let's just do the multiplication, A times U, and see what we get out. So we get 6 minus 30 is negative 24. And 30 minus 10 is 20. Okay, so that's pretty good. Is this an eigenvector? And it's okay to say IDK, but I would like to see a little bit of feedback, just to kind of confirm that I'm not talking to an empty room. We got a yes. Liza says yes. Great, you are correct. Liza says no. Yes, yes, yes. Okay, Liza, your first guess was correct, unless you're saying no to V. Yeah, it is an eigenvector, right? Because this is just, it's negative 4 times U. And so negative 4 is an eigenvalue. And the vector U is an eigenvector. Okay, and now let's do the other multiplication. Where did the -4 come from? Let's make sure I did this correct. Yeah, 4 as our first entry and 20 as our second entry. So it just came from observation at this point. Okay, now let's do the same thing with u. I'm sorry, with v. A times v is equal to 1562 times the vector 3, -2. Which is -9, 11. And this is not a scalar multiple of 3, 2. So this is not an eigenvector. So v is not an eigenvector. Okay, so where did this -4 come from? It's the scalar that you would multiply by. If you multiply -4 to the vector u, you get, it's the same thing as multiplying by the matrix A. Okay, so we found the number -4 just by observation. We'll eventually have some techniques to find it. But here we did the matrix multiplication. We got the vector -24, 20. Vector is an eigenvector. Did that help? Okay, well, let's do another example. Is this, are people in general? And see if this helps. Not really sure how to do that though. Okay, I'm gonna refresh.